Good afternoon, everyone, and welcome to everyone in the room, but also the panelists. Thanks for taking the time to, speak on this important subject. Of course, we are battling lunch now, so let's keep the session really short and crisp, so that we can deliver a good conversation here. So, Mr. Shankar, I'll begin with you. And I'll not introduce the panelists. We are running quite late. So, just jumping straight in, I think the bios of panelists are on the website. So you can, go and peruse there. So, Mr. Shankar, a lot of euphoria on green hydrogen from the past 2 years. But I think things are settling down now. Reality is also setting in. We have been saying that green hydrogen has a lot of applications, fertilizer, refinery, and all of that. But there are operational challenges that are now coming to the forefront. So how do we address some of these, operational challenges? So when it comes to fertilizer plants, we can't easily just blend hydrogen because it's all an integrated unit. When it comes to refineries, there are challenges with SMR units underutilized. So how do we thread the operational, the financial, the commercial, and still possibly make green hydrogen viable?
Thank you. Thank you. I will begin by straight away jumping into an out-of-the-box sort of an approach towards the question that was asked by the coordinator here, as well as it's a very meaningful question. And first of all, this whole euphoria that we are talking about is because of the one type of hydrogen production, and that's the electrolyzer. And the electrolyzer business is picked up in a big way in India, and everybody is looking at it. And of course, we are going to be challenged, if not nearly as early as in the next few years. But in the future, we are going to be challenged in a big way on the availability of water for this purpose. While one side, the Department of Science and Technology, as well as the government, is fighting the issue at the Supreme Court level to be able to make sure that people get water, we are here trying to create a whole energy source. So when we came in and I was talking to Jyoti Lal, one of the things that Jyoti told me was that it's essential that we look for something very unique that will also try to solve this problem. So we jumped straight into the subject of ethanol based. Not that we are going to be without a challenge. Ethanol is also going to face the biomass challenge. So we actually put money into that area and started working with the universities to create a huge biomass resource, which is taking shape. But unless you sow the seed, you can never be there to reap it. So we have started the things and we engaged some very senior people to work on that front. But in reality, we also approached the government of India with a project, joined hands with ANERT. And today we have a project that is in the final stage, or actually we have been indicated that it's been approved. And this is a project that will produce ethanol from, hydrogen from ethanol using a single reactor. Now, that's a big solution by itself. But then we addressed the issue of storage. We went into metal hydride storage systems, again, an existing prevalent system. While type 4 and other things are quite challenges in the future, they are going to be made available by others who are working in the area. So we concentrated on this area. Then we went into fuel cells. And using fuel cells, we tried to get into the entire area of production of power. And then the last one was dissipation of the produced hydrogen as a fuel as well. If you look at all these combinations, what comes to you is an answer with respect to a different route for hydrogen availability. But your question was more towards the euphoria related to all other things that are going around. Application of hydrogen with steel, application of hydrogen with respect to ammonia as a carrier, or methanol in that case. And these are all challenges that we are going to face, each one a technology by itself. And I already raised the subject of methanol production, where again the euphoria is around availability of hydrogen possibility and some CO2 possibility, but we don't have enough CO2, we don't have enough ethanol for even blending at this stage. Forget about post-blending. These are all some of the challenges we are going to face, and this is also going to get into other aspects, the availability of technology and at what price. Unless all those questions are addressed, it's going to be a challenge. One question will lead to another and multiple questions. So we are going to have a lot of challenges, and I think Kerala is a state that is focused on digital level of application of technologies. And I think we can take to advantage such universities as the Digital University. And we are also trying to work out on some specific solutions that you had alluded to. And I'm sure those challenges will be met in the days to come. I come from a province called Saskatchewan, where food, fuel, and fertilizer has been the base. And we have lived with innovation. 1 million people for a province that is almost as big as half of India. But we are having, and we are able to keep all the companies, whether it is SAS Power, Sask Energy, or Sasktel, everything on the black. And we are supplying power almost for 2,000 miles in one, north to south angle. How do we do that in a profitable manner? It's all planning. It's all, as they say, fiber to the house, and making sure that new technologies are innovated through eddy currents that prevent spoilage of systems. So how we overcome problems is, or take the challenge, is with innovation. And we are very good in it as a province, and we would like to do our best, as I am from India, and I'm trying to help the government of Kerala through an association. And I had a sister who was a former chief secretary here, and she and I get along extremely well. And she said, what you do well and best for the state. And that's my obligation.
Thank you, Mr. Shankar. I think challenges abound. And Siddharth, one argument that is being made is, why go for green hydrogen? Why not just stick to electrification? Because it's a plug and play model. Of course, one way to address that issue is improving the efficiency of electrolyzers, because the argument is that you lose 30-35% of the energy by the time you're making hydrogen, and then there is transport losses, and then there is end use. So what is your take on where do electrolyzers stand today, and how much more efficiency gain can we see? Also, in general, you're seeing a lot of confusion in the market on a lot of cheap electrolyzers being imported. How do we understand what is the lifespan of those electrolyzers, the degradation and all that? So really, two questions. Where will efficiency gains take us? Will we see something similar to what we have seen in other technologies like solar panels in terms of gains? And then from a current usage perspective, how do we understand electrolyzers better in terms of quality?
Two points to that. One definitely is the efficiencies of the electrolyzers. We already have electrolyzer technology. See, all of us, in a very loose way or a generalized way, we are all Google educated. We are not really educated in that sense. There are different kinds of electrolyzers which fit into different segments of the industry. So there is no one size fit all in that sense. If you look at the alkaline electrolyzer, yes, the efficiencies are about 60%, 65%. And when you're talking about inexpensive electrolyzers coming in, I would not use the word cheap, because it's definitely not cheap. You're all inexpensive in that sense. So the inexpensive electrolyzers are mostly coming out of China. And I always say this, that if you bid for a government tender, then you get electrolyzers from China, because that's a L1 tender. So Atmanirbhar Bharat generally works for China. That's what my allegation is lately. The second part is, if you're looking at developing your own project, then deploy a better technology. Not that alkaline is not a good technology, but better in terms of the shape, size, and also the efficiency. So there are technologies which are now at 75%, 80% efficiencies. There is a solid oxide technology that we also work on. We consume only 37 kilowatt hour of electricity. So we are at 92% efficiency. So these are all available. What is also happening in the industry, even on an alkaline level, is there is cell level densities. The current densities is what we are working on. And I think my colleague here, he'll be able to throw a little more light. He's from the academia, and they do a lot of research on that. So the power densities and the current densities have to increase, and they're increasing. So giving an example, if you again take solid oxide electrolyzer, That's on a capex level. So the current densities are at 0.6 ampere per centimeter square. We already have tried something at 2, and the theoretical limit that we can reach is 6. So say if we are able to even reach 4 amp per centimeter square, we are looking at the capex going down 4 times. See, and also the efficiencies are increasing. So we are literally going on that paranoid principle, the Intel principle, as they say. The size is coming down, the efficiencies are going up, and therefore the price is coming down. And this is a ongoing activity, and I've seen this through the last 15 years that I've been working into this. The first electrolyzer that I had built and that we worked on was for a capex cost of about $35,000 a kilowatt. Today we are even talking about $300 a kilowatt. So prices have come down, and they do come down. That's it's very organic the way it is going. Unless there is physics or chemistry stops you from reducing the cost. There are certain ways you just cannot do things. So the costs are definitely coming down. In terms of the application and what you mentioned about the round trip efficiency of 30%, 35%, you're only looking at one application, is electricity production. For me, using hydrogen to produce electricity is not a very good idea. We have other technologies to do that in a much better or an efficient way. Just like people in the biogas industry tell me that we are going to produce hydrogen from biogas. Guys, why aren't you producing syngas? Why aren't you just doing CBG? It's solving a problem, right? Why do you want to create another monster to just prove that you're doing hydrogen? That's not the route. So for hydrogen, we have to look at where it can be used, not electricity. Two principles. So if you're looking at India as a country, and that's what we focus on, is how I can decarbonize, how I can reduce my imports. So I think that's the priority for the country, is to reduce the import, and while doing that, decarbonize. So how do you reduce import? Is use hydrogen in places where importing more. You blend hydrogen with natural gas in your city gas distribution network. A 20% blend of hydrogen there will give you a calorific value much higher than what typical methane can give. So you're reducing import, you're also decarbonizing. Can I use that hydrogen, combine it with a carbon dioxide? We have an issue with carbon dioxide. Make it carbon neutral, make fuels. So like we are doing methanol and SAF using carbon capture with a co-electrolysis. Just like you do electrolysis, you do co-electrolysis, produce synthetic gas, and from synthetic gas you produce SAF. So those, if you look at those applications, that those are pretty large. And then there are applications where hydrogen is already being used. Refinery is one application. There is fertilizer, and then there is the specialty chemical. So the fertilizer industry, in my opinion, is a low-hanging fruit because we are importing a lot of ammonia. The specialty chemical is a low-hanging fruit because they are buying in small numbers, their costs are high. The refiners, they are already getting hydrogen at 150, 120 rupees. So till the time we reach that level, it will not be an incentive for them to buy. They will buy it because the government tells them to buy. But they won't buy it out of their need. And I always say this, that in a business, if you are buying because somebody told you to do so, it's not a sustainable model. You're buying because it is a need and you make sense, then it will happen. So these applications, if you really look at those and break them down, like I'm working on an application in the agriculture industry, just to give some numbers which may shock some people here. If hydrogen is used in agriculture industry just to decarbonize agriculture and make it more 24/7, I will need 95 gigawatt of electrolyzers. Much more than what the 5 million metric tons.
And what application is this in agriculture?
Farm to fork, everything. There are 118 million farmers. Let's give them 24/7 power. 74 million tons of foods gets wasted in warehouses. Let's give warm warehouses, distributed model, transportation, food processing, retailing in your house. Work on the distributed model. Let's not focus only on hydrogen. Let's not get enamored or fixated with that word. How I can do microgrids, mini grids, distributed level solutions. And I think that's where the real money and the real business opportunities.
Yeah, thanks, Siddharth. Alex, applications matter. I think a lot of conversation is usually focused on the large consumers, but clearly there are many applications in terms of distributed generation and use. So what are your thoughts on what sectors can smaller scale hydrogen be useful?
Yeah, so Sid took some of my talking points, so I'll do my best to add on. But I think I'd add on, we have to talk about the energy trilemma. We talk about, decarbonization, as he said, energy security, and then the third one is cost, right? And so to me, I think we need to use this as a frame. It should be doing at least one, preferably two, hopefully all three. So fertilizer, I think, is of course a use case where there's certainly an energy security angle. There's obviously decarbonization angle, and the cost, the green premium in fertilizer is relatively modest. The key here is there's a difference between the finance and the economics. So right now, fertilizer is very, very heavily subsidized. You need to take some of that subsidy that's currently going to natural gas and reallocate it to green hydrogen. So just to be clear, the overall cost to the consumer and the taxpayer is competitive, but it would require a restructuring of the way we fund fertilizer in this country. Another one that's more distributed would be these remote microgrids. So you see, for example, army bases, remote areas in let's say the Northeast or Ladakh, or littoral islands, like in the case of Lakshadweep and Andaman. And there, battery storage, I'm a huge advocate of battery storage, but if you're an island grid, 2, 4, 6 hour storage is insufficient. And when you get to 16, 24, 48 hour storage, that's when the solar plus battery for peaking plus hydrogen for your overnight power starts to make sense. So if I'm an army base, I need 24/7, I need 48 hour power. And then the third one is related to kind of CBAM, where you've got sectors like steel, for example, and you're seeing some companies using green hydrogen in terms of direct reduction for steel processes. And there, if the green premium is basically embedded in reducing your CBAM, that's where that's being paid. So I think these are kind of three example sectors. There's more, specialty chemicals, as Sid mentioned, say makeup and food processing and things. But I think we should kind of always have that in our back of our mind: energy security, energy economics, and decarbonization as a guiding principle.
Great, thanks. There are other applications like transmission towers also that can be looked at. I'll just plug in that CEEW has a research paper coming out soon on distributed generation and use of hydrogen, so do look out for that. Aravind, I'll come to you next with an accusation.
Thanks.
Just to keep this spicy. The general perception is that in India, academia and research is focused on research. We see you once in a while on conferences, but then otherwise, industry, does not get the right output from research. With what you're doing with the innovation hub, idea, how is it different from what has been going on for decades now in terms of research, generally speaking? And how do you intend to bridge that gap? To take on problems that are industry problems and provide solutions that are commerciable?
Great. I think that's a good question to start off with. And right before lunch, this is required so to keep everyone awake. Yeah, right. So academics, I think let me try to deconvolute it first, and then I'll talk about what our Hydrogen Hub is doing. So essentially, the academic institutes globally, let's leave India out, I think Western successful big countries, developed countries. The curiosity-driven research and new concept trials up to the proof of concept is always done in the academic institutes. Then institutes which will do scale up. There's industrial R&D, like the way we have our CSIR labs in India. We do have national labs in US, and take an example of Fraunhofer labs in Germany or Warwick manufacturing groups in UK, right? And they are the ones who typically do that industrial R&D. And then finally, once there is a pilot, companies take it up further. Whereas in India, I think somewhere we got into the confusion that everyone has to do everything. Somewhere this has happened, and that's for good reason. IIT Madras definitely stands out with that. In fact, our lab and H2E with Sri Siddharth Mayur, we worked on developing a hydrogen microgrid at IIT Madras, which is operational. We did a proper industry research out there. So before we frame, now things are changing. Like everyone has a responsibility to do something meaningful to the society and translate whatever we do at the lab to the next level, along with our continuous curiosity-driven research. So before we started building our Hydrogen Hubs proposal, I talked to almost 100 plus CXOs, me and my team, and that includes one sitting on to my right. A lot of suggestions came from them. We asked a question: what is it exactly we have to do as an academics in order to really enable the green hydrogen transition in India? And there are a few common things that evolved from almost all of them. So in fact, I lost a lot of my academic work during that year in 2022 end to mid 2023 because of this travel. Everyone said, if India has to really move to this energy dominance with hydrogen, we have to localize the supply chain and localize the manufacturing and use the existing expertise. And we took that as a tagline and then went back. What is the strategy to achieve this? Now I'm going to go from very small thing to very large thing. I'll take 2 minutes to explain that. There are many component manufacturers in India who are very MSMEs. They're very good at making that component today for big industries, very big industries. Automobile industry rely on MSME supply chain. Even today, I can bet that coating can be done very like best, or a corrosion resistant coating can be done really well by a small MSME. They understand it better. When you want to really scale it, but then their problem is the following. Someone has to test their product in a full system to make sure that their product is validated and then so that it can be taken to the next level. So our first objective at our hub is we will make a standard system. Let's say it can be electrolyzer, it can be a fuel cell. And if a company or an innovator comes out saying that I have this product, can I put it in your system? So I'll replace only that and put this new one in and then test it. This created opportunity for MSMEs. This created opportunity for startups and incubators to validate their product. So to validate it again, once we manufacture it, we have to test it. So we're creating a huge test rigs, huge amount of test rig opportunity. Then this is at where we are helping others. There are slightly long-range industry problems. Today, every academic are running behind catalyst development and all of that. I say we are far behind. We don't have an IP space. But we have a huge IP space in understanding the existing systems by improving their life, improving their safety, improving their performance. And that's our hub's focus today, right? And existing systems, whichever. Because I cannot cope up with a big electrolyzer manufacturer. The last portion of it is, once we test it in the lab, we always believe that it is done, but industry do the proper field tests. So we will be doing that at a field level, at a demonstrators. So covering all the way from component to the field level and provide a techno-economic assessment. And we are very fortunate that this is a project funded by Hyundai Motor India Limited today, to a quantum of $12 million. And a 65,000 square feet R&D hub is coming at IIT Madras Discovery Campus. And I think we have like Sri Jyotilal sir and Narendranath sir. So we really want to see these kind of innovators like from the administrative side to also help us giving the problem statements, bringing people together. We have good enablers at Guidance Tamil Nadu and Industries Department at Tamil Nadu who are helping us. We look forward to working similarly with here in state of Kerala as well.
Thanks, Aravind, and I hope we see more of that. Yes, Siddharth, you wanted to say something?
Just to defend, if there's acquisition that you made to him, just to defend him, we've been working with IIT Madras and we work with about 5 IITs across the country. The level of industry academia partnership that are happening right now, unheard of even 3 years back. So life always is pre-COVID, post-COVID. So whatever, there is so much work happening. I mean, we are working even with Anert, for example. We're working with a few colleges, local colleges, even in Pune, on this whole supply chain that Dr. Aravind mentioned. Because to indigenize everything, see, right now, even if we make it in India, it is assembled in India. We have to understand the distinction. So you have to make every component here. And that's where that supply chain, to get the industry capable of, that's where the academia is coming. So there is good amount of partnership work happening right now.
Yeah, thanks, Siddharth, and I think you answered one of my questions. But also, it's encouraging that people like you from the industry end are also taking the interest, because it's not a one-way street. I think what has not happened in India, and unfortunately, it's not a culture where industry gets involved in research and innovation. So it's very heartening to see that, and we wish you all a lot of success. Makrand, coming to you, talking about innovation. I think you have done already some things that we were hoping that we'll be able to achieve. One of them being, producing a, type 4 cylinder for hydrogen, storage and transport. Perhaps very quickly you can explain to the audience, what is the difference between a type 4 and the rest of the, categorizations. And then, also whether your cylinder is 100% indigenous.
Yeah, first of all, thank you, Anat, and thank you, Dr. Jyotilal, for inviting us here for this panel. It is a great event. So coming back to the question, yes, currently, I'm just 2 weeks old in this organization, Time Technoplast Limited, but I'm proud to say that this is 30-year-old organization, 100% indigenous organization. And let's talk about a little bit technicality of the hydrogen storage system. So there are various storage systems are available in the market. Some are with a good TRL level 8, 9, and some are in the TRL level 3, 4 to 6 under development. So basically it's a physical storage versus chemical storage. That's how we categorize. And Time Technoplast is involved in the physical storage, specifically in the gaseous storage form. So under this, there are 5, we categorize in 5, type 1, type 2, type 3, type 4, and type 5. So basic difference is, if you look at the weight of the tank, okay, per liter volume, so the type 1 is the heaviest one versus type 5 is the lightest one, okay? Accordingly, the cost economics goes reverse. So type 1 is the cheapest and type 5 might be the costliest at the moment. But if you look at the pressure levels, what it can carry. So type 1 generally 200 to 250 bar, type 2 in the same range, type 3 maybe up to 350 bar, type 4 has a capability of 350, 700 and up to 1000 bar, and type 5 might be very similar like type 4. When it comes to the materials being used, so type 1 is basically all metal cylinders. Okay, type 2 are metal cylinders with a certain lining in middle part of the cylinder. Type 3 is also basically a metal liner, but then fully covered with the carbon fiber filament. Type 4 is a polymer or plastic liner, but fully covered with the filament. And in type 5, there might not be any liner. It will be completely carbon filament. So looking at the innovations, what Time Technoplast has done recently. So we have got recently developed this type 4 tank with various capacities of the water volume. And before that, we were actually in the business of CNG storage and those kind of storage system for cascades and also for the onboard storage. So we have around 700 cascades already in the market for CNG, okay, which are being utilized by the various energy companies, gas companies. And we have the approval for the type 4 for hydrogen cascade, which you will soon see. So we are right now setting up the innovation team, and that is one of my responsibility here in this organization, to how to make the cascade more smarter, how to make it lightweight, how to reduce the transportation cost of the hydrogen. Ultimately, it is directly related to that, who is operating or who is going to use our product. So they are going to talk about the capex and opex of our product. So yeah, these are the basic differentiation between this.
Yeah, thanks, Aravind. Question for you, and let's keep this short. I think we have very little time. There is a debate in the transport sector whether it should be EV versus hydrogen. And within hydrogen, there's a lot of activity on hydrogen ice. Again, something that befuddles me on, a 35% efficiency, in an ICE engine, but still there are OEMs targeting, hydrogen ICE. So what's your take on EV versus hydrogen ICE versus FCEV?
Great. I think in the previous panel, someone said there is nothing called like this or that. I think it's going to coexist, but I'll defend with one number. Today, let's take any truck can have at least 1 megawatt hour battery. I'll start with the battery-based vehicles. And if assuming we're targeting 1 hour charging, fast charging, meaning one vehicle requires 1 megawatt power, and 1,000 vehicles require 1 gigawatt power, right? And I need a power plant for 1,000. And India has today around 3 crore vehicles, and out of which nearly 30 to 40 lakhs are like really heavy vehicles. And you can imagine the number of power plants required for that. And so we are going to collapse the grid. So we need to create local solutions for the hydrogen generation, and that can be used for the heavy duty trucking. So it's not about just the hydrogen or batteries that we need to compare at the vehicle level, but rather at a full system level as a country we need to look at. That is about the hydrogen and batteries. Between fuel cell and combustion, it can be an internal combustion engine. So we don't know. I'm hearing all sorts of thoughts based on my experience and all of that. I think we just have to wait and watch which is going to work. Because fuel cell is always considered quite expensive, but it's a time-tested technology. ICE is coming up, but it's not that. ICE is also very well known and people know how to make it to happen. So we just have to wait and watch which is going to take a lead. Yeah.
Got it.
So maybe I'd like to add something,
Sure,
because just before this, I was part of the completely automotive industry. I was part of the Volvo group working on H2I's fuel cell application for automotive. So both are good. currently the only challenge when it comes to the fuel cell vehicle is the cost. Okay, the capex is very high, so we do not see any business case right now happening. Okay, down the line, yes, it will be, but H2Is, as my colleague said, yes, it's a proven technology, very well known. We know ins and outs. We means whole industry knows, and it's very easy comparatively to convert from diesel truck to the H2I truck. So whatever delta comes, the major delta actually comes from the storage system, not from the technology for which is required to be changed. And I strongly believe that not all the segments of the automotive are suitable for hydrogen. Okay, there is no silver bullet, there is no one. So all solutions will coexist depending on the segment. As we mentioned, heavy duty sector is very good segment for the hydrogen, because it is very difficult to get the good TCO, that is the total cost of ownership, which the fleet operators with the EV in the heavy duty sector, where the daily range is around 800 plus kilometers. Technically you can make, but the cost economics may not be good for that. Those sectors are very good for the hydrogen. It could be H2Is or fuel cell, but starting with H2Is might be the good solution.
Yeah, since you're holding the mic, Makrand, I'll ask you, one more question. We did some very back of the envelope calculations, and you mentioned total cost of ownership or operations, right? We find that it's not simply the capex that is problematic. It's also the weight that batteries, take. And that's because when you're looking at the freight sector, a very, rough calculation tells us that, with an FCEV and hydrogen storage combination, you're looking at 1/4 the weight for the same energy density that EVs would provide in terms of battery, right? So the point I'm getting to is one of the big challenges in making hydrogen cost competitive compared to EV is the weight of the cylinder itself. So a substantial portion of the weight of that cylinder, I mean, you might carry only 5 or 6 kilograms of hydrogen, but might carry 100 kgs of the cylinder itself. So my question is, are there initiatives to reduce that weight? Because we feel if that overall weight comes down, your range increases, the operational time of the truck increases, which means then, battery becomes less competitive compared to EV. Not that, or hydrogen, not that we have a preference one way or the other, but that's where the barrier is. So what's your take on how do we reduce the weight of the cylinders?
Yeah, so that's a very important question when it comes to the operating cost of the vehicle. So yes, today it might look like, even so, for example, if someone is saying I will go with type 3, type 2 or type 1, it is going to be extremely heavy. And that's why type 4 kind of tanks is very important for the mobility applications and also for the transportation or cascade. And to answer your question about the weight reduction, I think there are innovative solutions which we are in the process of developing. These solutions include the design optimization of the tank. The solution also includes how to reduce the filament winding required per cylinder. Okay, this also involves a lot of simulations which auto industry is doing, but now it should also come down to this industry, like if I make a different kind of winding, different shape of the winding, different layers, number of layers of the winding, what is the strength I am having at 350 bar, 700 bar? What kind of specification I will be able to meet with those reduction in the weight or reduction in the filament? And I do also see that okay, time Technoplast in not in the raw material manufacturing like carbon fiber, we take it from somebody else. But within that space also, there is a lot of improvement is happening about how to increase the material strength of that particular without increasing the cost or without degrading the quality of it.
Thanks,
Yeah.
Makrand. Mr. Shankar, one of the challenges we have seen in this part of the world, especially in India, is people like Makrand, if they have to produce and innovate, or even if Aravind has to, Aravind is creating his own test facility. But that's not true of all the other components, subcomponents in India. You have to often rely on third party outside the country to do your testing, which is not the case in developed countries. So how do we encourage private sector in India to either set up or manage test facilities so that it's an open platform for others to come and innovate without having to rely on someone outside the country?
Yeah, this is working. So my answer to this question is, it's basically something that we have to learn from outside the country. I'm making it very simple. I know there's a big tender that's going on in this country right now, offering money from the government and incentives to be able to set up test systems. I think many companies are bidding on such a possibility. Look at the core material itself. What are you not having that you are getting from outside? It's carbon fiber. Without it, you are not able to do it here. Okay. Therefore, you try to get into composites. Now they are in composites. You could see what the foreign companies are doing or countries are doing with composites. How do you reduce the weight vis-a-vis its performance to be able to withstand pressure, vis-a-vis the overall weight as well and the cost, right? These are the four compositions. In this particular case, I was at a meeting with NALCO, and NALCO was asking me examples of, have you seen these sort of type 4 systems? And it's very simple. They impregnate aluminum into the system of composites. In India, you know that even composites have got their own problem. If you use a not proper resin, you are not going to be able to bind them. And there's only one company making it in India, and that I think is the Birlas. So what I'm trying to say is, look at how powder chemistry and such things are involved in strengthening the bonds of the composite material. Well, I gave you a clue already, aluminum. But somebody has to take it up, see how you can get to the nano level of deposition and how that can improve the strength. It's almost like having a double-walled vessel built in one into the other. And since you are nano posting it into these composite cells, it has the type of, but nobody is doing work on that. And that's what I would encourage. Same thing with supercapacitors. You look at the supercapacitors, you need graphene. And I was so happy when a project that we had conceived was approved by this very gentleman sitting here, asking us to go. In fact, they gave us a priority to go for production of graphene because I am planning to produce graphene-based supercapacitors. And that even the other gentleman here who was on the dais talking about financing, he said he will make it an easy one to finance, mainly because, so innovation comes sometimes, you should not be afraid of copying what's going on. Read a lot of literature. Every PhD has got to do that anyway. Put your postdocs on those jobs, get them to work. And that's where institutions like IIT should. I have started to respect this gentleman a lot. I'm visiting his place. And Pratibha, for example, in IIT Mumbai, they do intense work, but go to the micro level of the need. And then you have solutions. And that's where academia should spend their time. That's why we have defined TR levels. And we are not serious about TR levels in India. So if you want to fund projects, go by TR levels. And then you will see finance creeping into those projects as well. That's my humble opinion.
Thank you. Alex, last question to you. I guess a lot of problems to solve, but clearly India is not the only one who has to solve it. There are other countries who are very keen to collaborate with India. So how do we, form these partnerships for R&D and innovation? Are there mechanisms available, platforms available where our innovators can solve common problems and also probably at a lower cost and bigger market? So any thoughts on that?
Yeah, so I mean, firstly, I think this is a huge advantage for India is that, the innovators we see, so some of our portfolio companies like, say, Precinto or Green Pod Labs, developing technology in India that is both world leading and also cost competitive. And then, organizations like Third Derivative, we can help them kind of scale abroad and expand abroad. You also see organizations, like this collaboration this morning, the Denmark and India and co-funding PhDs. But I do think we also need to bring more money to the table, right? You see these PLI schemes with 20,000 cores for manufacturing and 600 cores for R&D. And then you go actually ask and say, well, actually only 10 is being dispersed, and people have to fight tooth and nail. And I've met so many incredible companies. Whether it's Hyerton is here today. Even just getting a few core to do set up your own lab, to get the equipment, to do the pilot project. This is something we need a lot more money towards earlier stage startups where the innovation's happening. And then secondly, I think scaling up, right? You see companies like Nutrace or Ossis, which have or H3 Power, which have done great work, great pilot scale. Now, how do we get larger projects? How do we get PSUs willing to take that green premium and say, we're going to pay this green premium to allow you to do the 10 megawatt project or the 100 megawatt project, sort out the kinks, get that economies of scale to then bring down the cost where it's cost competitive. And then finally, it's being having the support to then go abroad, whether it's selling in Europe or selling in Japan, and I think the government's done a great job kind of marketing the India story in terms of as a hydrogen supplier or a green steel provider around the world. But at the end of the day, that story needs to be backed up with dollars or rupees in this case.
Yeah, please. That's a very interesting thing. When you want to get this sort of material investments into a product to strengthen its qualities, I would refer to people to go into institutions like the light source, for example. The Canadian light source is there in Saskatchewan, and there are regular proposals where you can study this sort of material configuration. Now you're talking about composite and an aluminum here, and so that study you can see it at the best level that you can see, that sort of ideas I used to get from no less than a person than Dr. Chidambaram. Of course, now he's late Chidambaram, and he was with IIT as the chairman as well. And now you got a very interesting guy who is the present chairman, who is a good friend as well, who had come from the automotive industry, right? So it's very easy to take it up to him and say, I want to use the light source. Why? I want to use it for this purpose. And that's, once you go like that, then if that idea is not acceptable, then I will blame the trainers of the trainers here. That's the professors who are inadequately equipped to know and knowledge of these things. So you better go to somebody else and get the best help that you can. It'll help you. And I think that's the way we have to go. Sometimes bypass the system if needed to get to the objectives that's needed. And going to big companies and getting support is not difficult in Canada. And I've seen that happening again and again. And he's here as a colleague of mine, I can tell you that. You go with
Thanks. I think generally at the ecosystem level, industries don't yet trust our R&D and innovation systems to be able to invest. But I hope, with initiatives like what Aravind has done and support like what Siddharth is giving, that tide will change. We are very hopeful. Any last points any panelist wants to make before we open for questions?
Yeah, in the context of academia and industry relationships. So by God's grace, I got a chance to work with different OEMs, different parts of the world. And what I have seen as a part of development in Europe, a lot of OEMs actually depend on the academic research at the very pre-stage of the product development because their facilities are like that. Second, it's not only the facilities, it's also the people who work in those research fields. They have the good understanding of the what industry wants. So the difference or the gap between your TRL level 5 to TRL level 9, how to meet this gap. And many times I have also seen many of these academic research people also go to the industry for 3 months, 6 months orientation program. They sit in the industry, they sit in the industry office and try to understand their process of development, their actual requirements, and also more importantly with their cost people. At what cost this technology will fly in the market. So this kind of setup maybe we should promote also in India.
Yeah, absolutely. So there is the Anusandhan National Research Foundation. Hopefully, that plugs the gap that we all see. So I'll, pause here. If there are a couple of quick questions that anyone has, we can take it. I don't see any hands. Okay. I don't think there are any questions, but thank you very much for being a patient audience. I know we have kept you away from our lunch, but we'll close it here. Thank you, everyone. Thank you, all the panelists, for taking the time today. Thank you.